Hello everyone. In this lecture, we are going to discuss about conversion of PDA to CFG. So let PDA P is given, that is PDA accepted by empty stack is given. Then we can construct its equivalent CFG. That is the language accepted by PDA P can also be accepted by CFG G. So the PDA P is equal to Q sigma gamma delta Q naught Z naught is given. Then CFG G can be constructed with the 4 tuples set of variables V sigma R S, set of variables, terminals, set of productions or rules, and start symbol of the grammar. Here set of terminal symbols are the input symbols of PDA. So if sigma is the input symbol of PDA, that sigma is a set of terminal symbols of CFG. So this component is same. So here sigma and here terminal symbols are sigma. Now we need to know about the remaining 3. So set of variables V for the CFG can be constructed by using these 2 rules. One is the special symbol S. S is the start symbol of the grammar also. So S is the start symbol of the grammar. That is also included in variable V. So for all the problem, for any example, we have to consider S is the start symbol of the grammar. So that is one of the variables. Then all the other variables can be formed with this form. So all the other variables can be written by using the square bracket. So within the square bracket, we have to write PXQ. Means P and Q, where P and Q are the states in Q. For example, if PDA has Q0, Q1, Q2, then we have to write form all the variables with Q0 x Q0, Q0 x Q1 like that. So where this P and Q, first symbol and last symbol are the states in Q, and the middle symbol X is the stack symbol. Okay. So first symbol and last symbols are the states, middle symbol is a stack symbol. So this is considered as a single variable. Okay, S is considered as one variable. Other variables must be formed for all possible combinations of the states and all possible combinations of the stack symbol. So we have to construct variable like this. Then productions, so variables formed by following these 2 rules. Then we need to form the rules. So there are 2 rules. So first one is for all states P in Q. For all states P in this capital Q, we have to write the set of productions like this. S tends to, that is the start symbol of the grammar S. Start symbol of the grammar S tends to Q0, Z0, that is within square bracket. It's a variable, single variable. So within square bracket, the start state of the PDA Q0, starting symbol of the stack Z0. Then for all possible combinations of P, we need to write this. So for example, if the Q has P and Q, there are 2 states P and Q, means then the productions are S tends to Q0 Z0 P, then S tends to Q0 Z0 Q. So this rule must be written for all possible combinations of this symbol. So first 2 symbols are Q0 Z0 only. And that means start symbol of the, starting state and starting stack symbol. Then this state, this must be written for all states in Q. Then for the second rule should be written for all the transition function of the PDA. For all transition function, we have to follow this rule. So consider it as a transition like this. Del of Q, comma, A, comma, X equal to R, comma, some k number of symbols y1, y2 up to yk. That is the current state of the PDA is Q, current input symbol is A, top of the stack is X, and the next state is R, and this k symbols, this string replaces symbol X on top of the stack. That is push operation. Means then how to write the production for context free grammar. If PDA has a transition function like this, then production we have to write like this. So a variable can be formed by combining this Q, X, because variable can be written like state, stack symbol, state. So this Q, X and RK, and this must be written for here K symbols are there, so we need to use K variables must be written here. So assume that the set of states are R1, R2, dot 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 to RK. K number of states are there. Then for all possible combination of the state, we need to write this rule. So QX, 1 is written here. So QX, this RK tends to QX, this Q and this X, then RK tends to the terminal symbol A. Then we have to write K variables here. Here K symbols are there, so K variables should be written. So this R should be written first. So R and Y1, then the new state R1. And whatever state written here, that must be written here also. So R1, then the next stack symbol Y2, then R2. Then the next variable must be R2, Y3, R3. Okay, likewise we have to write. So the final symbol is here R1 means Y2, R2 are coming. So that RK minus 1, YK, RK. So this and this must be same. In every production, this current state should be written here and top of the stack. Okay, current state, top of the stack, and a state. This rule must be written for all possible states. So here RK is written means the final state. Here also the final symbol should consist of RK at the end. So this and this must be equal. And in the right hand side, after the production symbol, in right side, we have to write the terminal symbol here. Then this R should be written. Okay. So this Q, this X, and this RK and RK should be equal. Then this Y1 should be written here, this Y2, Y3 up to YK. So these symbols, these are the stack symbols, must be written in the middle part. And this R should be written over here. The first symbol and final symbol must be equal. First state, this state and the final state. This should be equal. And in the middle portion, we have to write whatever state is written here, we need to write it here. So R2, R2, R3, R3, likewise we have to write. So if two symbols are given here, then two variables must be written here. One variable is written, then one stack symbol is written here, then one variable should be written here. So sometimes this may be epsilon. For example, del of Q, A, X equals R, epsilon. So in this case, we have to write Q, X, R. Q, X, this R tends to A. It has only one production, but this must be written for all possible combinations of the states. Okay, in the example we will see that. So for the K, more than one symbol, one or more symbols, we have to write the rule for all possible combinations. But here epsilon is given, then we need to write only one production by combining Q, X, R, then production symbol, this A should be written. This is second form. Third form is sometimes this A may be epsilon. So del of both A and here epsilon. So epsilon X equal to R, epsilon. So here and here both may be epsilon. So in this case we have to write Q, X, this R implies this epsilon. Okay. So these are the three possible combinations. So here one or more symbols may come. If epsilon is coming and single terminal symbol is there, then we need to write only one production like this. Then both these two symbols are epsilon. Here also we need to write only one production. Now we will see an example. So the example is convert the following PDA into CFG. So 6-tuple notation and the 6 transition functions are given. So now we need to construct set of variables for our context free grammar. So the variables V can be written as the start symbol S. We need to consider S as a starting symbol of the grammar. So it is included in V also. Then terminal symbols are input alphabet of P. So we have to construct set of variables and productions alone. So yes, comma, then all possible combinations of state and stack symbol, right? So first here there are two stack symbols and two states. So we have to first consider the stack symbol in the middle. So we can get four possible combinations, right? So QXQ, QXP, then PXQ, PXP. Similarly, we need to consider Z in the middle. So QXQ, QXP, PXQ, PXP. So there are four states, four variables we can frame by considering X in the middle. Then we have to write Z in the middle. So QZQ, QZP, PZQ, PZP. So these are the 8 variables formed for the context-free grammar. So these are the set of variables. One is framed from the rule. First rule, yes. Second, we have to construct all variables in the form of PXP, where P and Q are the states in Q, X is the symbol in gamma. So we have got 8 different states. Then we have to construct a set of productions. So by following first rule, how to form the rule? The start symbol of the grammar S tends to Q naught Z naught. Here the start state is Q and the start symbol of the stack is Z. So QZ, and this P is for all states. So here how many states? There are 2. So first we have to write Q here. Then one more production, S tends to same Q naught Z naught. So QZ here, QZ, and here we have to write Q, P, right? So S tends to, start symbol of the grammar tends to starting state, starting stack symbol, and this symbol must be written for by considering all states. So QP. So these are the 2 rules we have framed by considering the first condition. Then the second condition, here there are 3 parts. So it may be a push operation or pop. In pop there are 2 conditions. Here a terminal symbol may come or epsilon, and sometimes no change symbol. No change operation means here we will have only one non-terminal. So for that also we have to follow this rule. So now we can write, we have to consider all the transition functions one by one and write the rules. So now I have to consider all the transition one by one. So first I have taken the first transition. So here there are 2 stack symbols. So we have to write 2 non-terminals in the right side. So first we have to write this Q, Z, and this symbol must be written for all combinations of the states. So first I am going to write the rule for Q, then I will write the rule for P. Okay, so Q, Z, this Q implies this terminal symbol 1, and how can I write these 2 variables? By combining this Q, X, QX, and here also I need to write the state one by one. So first I have to write this rule by writing Q in the middle, then I have to write the same by writing P in the middle. So first I am going to consider Q. So Q, whatever state I have written here, I have to start in the next non-terminal. So Q is written here means here also I have to write Q. Then Z should be written here, Z, and this same state should be written over here. So Q, Z, first I am going to write Q here. So Q, Z, Q tends to 1, Q, X, then Q, then the same Q, Z, and this Q must be written over here. Then the same rule I have to write by writing P in the middle. So Q, Z, Q implies 1 into Q, X, P, P. ZQ. So in the middle portion I have to write P. So now I have written the two productions by considering Q here. Now I need to write the same two by considering P in the end. So Q, Z, P. This Q, Z and P implies 1 into QX. First I have to consider Q in the middle. So I have to start the same Q here, and this Z must be written and this P should be written at the end. So now I need to write the same production with P in the middle. So QZP tends to 1 QZP tends to 1 QXP PZP. Okay, so this state must be written here. Then the stack symbol must be written for all 4 possible combinations. Then I have to write 2 rules by considering Q here, then P. Because first I have to consider Q in the middle portion here and P. Similarly, in P also Q and P. And whatever state I have written here, that should be written at the end. And here the terminal symbol should be written. So 1, and this must be the state Q, and this is X. And here I have to write all possible. I have already told QQPP, QQPP. And here we need to write this symbol. So Z, and here whatever state written here, that should be written over here. So QQPP. Now I have taken the second transition. So here also there are 2 symbols here. So we will get 4 possible combinations because it has 2 states. So we will get 4 possible combination. So QX. First I am going to write for Q. So there are 2 rules, QXQ. So 1, this QX. First I am going to introduce Q here. Then the same Q. The second symbol is also X here. So X and this Q should be written here. Similarly 1 QX. Now I need to write P in the middle. So P X, this Q. Now I have to write the same, but instead of Q I have to write P. So these 2 symbols must also be changed. So QX P tends to 1 QX Q, the same Q X P. Then QXP implies 1 QX. Here I am going to write P. PX, this P. So now fourth one. Fourth rule is third transition function, because I have considered this as first step. So fourth set of productions can be formed from the third transition function. So del of Q comma epsilon comma X equal to Q comma epsilon. So here epsilon and epsilon came. So we will get only one production. So Q X Q. This is a variable. So QXQ implies epsilon. Then the next one is this rule. So del of Q0X equals P comma X. So here we have got one symbol. Okay, in these 2 rules, 2 symbols, but here one symbol is the stack symbol, that is no change operation. This X replaces X on top of the stack. So we will get 2 productions here. Okay, one with Q, another one with P. So I have to write QX. First production I need to write with Q here. Implies this 0 P X, and this Q should be written at the end. Then another production I need to write Q X, and I have to consider P here. Implies this 0 PX and this P should be written over here. Okay, then sixth rule is I need to write this. Sorry, this one. So del of P comma 1 comma x equal to P comma epsilon. So here epsilon is coming, but here the terminal symbol. But in this case also we will have only one rule. So P x, this P implies 1. Then the final function is del of P comma 0 comma z equal to Q comma z. So here also one non-terminal, no change operation. This z replaces z on top of the stack. So we will get two productions like this. So P z, I have to consider Q first. So P z Q tends to 0 Q z, this Q at the end. Then the next one is P z P at the end tends to 0 QZ, this P at the end. So these are the set of productions for the context-free grammar. So our context-free grammar has the set of variables S and these 8 variables. Set of terminals are sigma, that is 0 comma 1, and these are the set of rules. Starting symbol of the grammar is yes, and here we have got two productions for yes, and if we have two symbols here, then we will have 4 productions. Okay, 4 productions, but the condition is here there are 2 states. If the PDA has 2 states and 2 stack symbols are coming, then we will have 4 combinations of productions. Otherwise, suppose if the PDA has only 1 state, means we will get 2 productions only. Okay, and in this condition here 2 states and 2 stack symbols are coming. So for the 2 symbols we will have 4 possible combinations here. For the single symbol we will have 2 possible combinations. If this one is epsilon, then we will have only 1 production. Okay, so this is the equivalent CFG for given PDA. Thank you.